Let us look at proposition number 71 of book 10 of Euclid's Elements. The proposition says, if a rational and a medial areas are added together, then four irrational straight lines arise, namely a binomial or a first bimedial or a major or a side of a rational plus a medial area. Okay, let's see how we can prove this. Let AB be rational and CD be medial. Now there are two possibilities. AB is greater than CD or AB is less than CD. It can't be equal because AB is rational and CD is medial. So these are the two possibilities. So let's take the first case of AB greater than CD. Set out a rational straight line EF. Apply to EF a parallelogram EG equal to AB. Now here, since it's a parallelogram, EF is equal to HG. So now we apply to HG a parallelogram HI equal to CD. So breadths EH and HK have been produced. AB, a rational area, has been applied to a rational straight line EF, which means EG is rational, which means EH is rational. So EH is rational and commensurable with EF. Okay. Now CD is a medial area and applied to a rational straight line HG, which is equal to EF. So HK is rational and incommensurable with EF. AB is rational and CD is medial. They are incommensurable, which means EH is incommensurable with HK. So EH and HK are rational and commensurable in square only. That means EH plus HK, that is EK, is a binomial divided at H. Since AB is greater than CD, it implies EG is greater than HI. EH is greater than HK. If EH square is greater than HK square by a square on a straight line commensurable in length with EH. EH, the greater, is commensurable in length with EF. Means EK is a first binomial. Now, EI is equal to EF by EK, where EF is rational and EK is first binomial. So that means the side of the square equal to EI is binomial. Means side of EI is binomial. Since EI is equal to AD, side of AD is also binomial. Now, if EH square is greater than HK square by a square on a straight line incommensurable in length with EH, EH the greater is commensurable in length with EF, then we can say that EK is a fourth binomial, and EI, which is EF by EK, where EF is rational and EK is fourth binomial, side of the area EI is a major. Since EI equal to AD, side of the area AD is major. So what we have shown, that if AB is greater than CD, and based on these conditions, two irrational straight lines arise, binomial and major. Now we have to show the other two, that is first bimedial and the side of a rational plus a medial area. So now let's look at the case where AB is less than CD. EG is less than HI because AB is equal to EG and CD is equal to HI, which implies EH is less than HK. Now, if HK square is greater than EH square by the square on a straight line commensurable in length with HK, and EH, the lesser, is commensurable in length with EF. So we can say EK is a second binomial, and EI, which is the rectangle contained by EF and EK, where EF is rational and EK is a second binomial, the side of the square equal to EI is a first bimedial. The side of EI is first bimedial implies side of AD is first bimedial. And now let's look at the last case where HK square is greater than EH square by the square on a straight line incommensurable in length with HK. So EH, the lesser, is commensurable in length with EF, because remember EF is rational and EH is also rational. So we can say EK is a fifth binomial. And the rectangle contained by EF and EK, where EF is rational and EK is a fifth binomial. So side of the square equal to EI is a side of a rational plus a medial area, which means side of AD is a side of rational plus a medial area. So we have shown that if a rational and a medial are added together, then four irrational straight lines arise, namely a binomial or a first bimedial or a major or a side of a rational plus a medial area. That was proposition number 71 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.